All right, we'll do a quick one here on why it's important to load test a circuit or load test wires when you're troubleshooting electrical. So I've got an EX750 here. So the customer lost swing function and one of the tracks. And they found a broken wire on that pump control solenoid. And they replaced that, but it didn't fix the problem. So I hooked up the laptop, I checked all my sensor readings, checked that the pumps were actually being commanded by the controller to stroke up. Everything looked good, but the pump wasn't working. And here's where load testing comes into play. So service manual might tell you to go to this connector and check from pin A to pin B and you should have X amount of volts. Or to check from these back to the controller, you should have so many ohms of resistance. But one strand of this wire will carry system voltage and it will give you a good ohm reading. So I came back here with a meter and all that checked out. And this is something I was taught a long time ago, but I took my test light because this puts a load on the system. I came to that connector and my voltage would drop to 0 and the bulb wouldn't come on. So now you need to know, is our issue in the harness or is the issue in the controller in the cab? So I unplugged my connector and I put a jumper in place of that solenoid. Came into the cab and I disconnected the connector from the pump valve controller and I sent 24 volts through that circuit out to that connector and back, and then I put my light in place and the light lit up. So now I know my wiring from the controller back to there is not shorted out and it will take a load. I hooked everything back up and then I back probed my power supply out to that solenoid, and in the cab here with my light I could put my light on there and I could watch my voltage drop from 24 down to 0 and I would get nothing on the light. So now I've determined the issue is in fact inside the controller. So you're talking in the span of about 15 minutes, I've verified with my laptop the controller is trying to do what it's supposed to do. My wiring is good, but I'm not getting the correct current out of the controller to the solenoid. And inside the controller, we were able to verify that it is burnt and this controller is bad. I actually had a spare one in the cab from previous years of troubleshooting, so I was able to swap it out and get it fixed. So voltage and resistance, they're important. I would say that's step one, but they don't tell you the whole story, and some of the troubleshooting manuals will mislead you on what you should be looking for. Sometimes you really need to put a load on the circuit to see what's going on. And some guys are real big fans of the test lights. I use them sometimes, but I have seen some of those that will light up on a circuit indicating there's voltage and current there. You take something like a light bulb that actually requires some real current and it falls on its face. And you'll see guys talking about the load cage on here. Not knocking the guy, good for him for making a product, making a buck, but it is a light bulb in a housing. Guys have been doing this for a long time. It's just been forgotten about. And if you look in some of the old troubleshooting manuals for some of this equipment, it will show you taking a light bulb or a test light like that and loading a circuit. It's been quite a while now, but at one point I did make a video showing where you can use a test light like that to find a short in a harness. If I can figure out how to do it, I'll tag it in the bottom of the video because it's super simple, but I see a lot of guys that don't know how to do it. And there's other ways of doing that too. And let's say you've got a sensor that's not reading right, and the book tells you to unplug the sensor and check your 5-volt feed to the sensor. You got your 5 volts, all's good. Now plug the sensor in and back probe it and see what that 5-volt reference is. Because if that wire's messed up and it can't carry the load to that sensor's not going to read right. So unplugging something and saying, yep, my voltage is good, matches the book, does not mean that circuit's good or that component's good. So it's just one more thing. Check your voltage, check your resistance. Everything checks out, put a load, make sure it's actually working right.